I need you to pay close attention, because in this video, I'm going to solve in detail each of the math exercises from the 2026 Guide for Admission to Undergraduate Studies at UNAM. Specifically, I'm going to solve the ones from Area 3, that is, the ones from the Social Sciences area. So come on, let's get started. The first math exercise that appears in the guide is exercise number 41, and it says, the result of we have an operation is, and we are given 4 possible answer choices. Look, the first thing I'm going to do is first add this positive with this other positive. I say they're positive because remember, if there's nothing in front, it really means the number in question is positive, right? So, come on, let's write down this number and let's add this other one I have here. So we write 0.1709, and to this we're going to add 1.1783. It's absolutely necessary to remember that when we're adding numbers with decimal points, the decimals, that is, the decimal points, must be aligned. Okay, so come on, let's do the addition. 9 plus 3 is 12. Carry the 1, plus 0 is 1, and plus 8 is 9. Then 7 plus 7 is 14. So I write 4. Carry the 1. Plus 1 is 2, and plus 1 is 3. We bring down the decimal point in the same direction and add 0 plus 1. 0 plus 1 is 1 done. The result then, after adding the 2 positive numbers, is 1.3492. Now what I still need to do is subtract this 2.91. So, the operation I would have to do, let me write it here in black. So the operation would have to be 1.3492, which is what I got from adding those 2 positive numbers, minus what? 2.91, and then, but look, we really can't do this subtraction directly. Why can't we? Well, because this negative number is actually bigger. Okay, therefore, we can't do the subtraction like that. I mean, I can't just subtract it directly. With this process, I can't subtract a bigger number from a smaller number. So what I'm going to do is reverse the operation. That is, I'm actually going to do 2.91 minus 1.3492. And then, whatever result I get, I'll just change the sign. Look, follow along with me so you can see what I mean. So I'm going to write 2.91 first. Okay, I put the minus sign, and now I'm going to write 1.3492. Don't forget, we have to line up the decimals, so I write 1.3492. See, what I'm doing here is expressing this same operation, just the other way around. That's really important. Okay, now, to be able to do the subtraction, I need to fill in here, right? So I put a 0 here, and also put a 0 over here. And now, let's go ahead and do the subtraction here. It's important that you also remember how to subtract numbers with a decimal point. Okay, so here we go. I have 0 minus 2, which can't be done, so we borrow, and it becomes 10. 10 minus 2 is 8. We bring it down. Let me change the color. So it would be 8. There we go. Now, this one here isn't enough, so we borrow, and it becomes 10. But since we borrowed, it becomes 9. 9, right? 9 minus 9 is 0. This one here already lent, so it becomes 0. It's not enough, so it borrows, and becomes 10. 10 minus 4 is 6. This one here now became an 8. 8 minus 3 is 5. We bring down the decimal, and 2 minus 1 is 1. Careful, the result of this subtraction is 1.5608. But that wasn't the operation I had to do, right? I had to do this one over here. So the numerical value has to be the same, only the result will be negative. So we're going to put minus 1.5608. This one right here. Now this will be the result of the operation. So, let's see. Which one will it be? Is it really the one? Done. It's working out for me now. So, the correct answer is the one over here, in option D. We're done. Easy, right? Perfect. So let's move on. Let's go now with exercise number 42. which says a car travels 48 2/5 of a kilometer with 5.5 liters of gasoline. What was its efficiency in kilometers per liter? All right, let's go. The first thing we should notice is that here they are asking us for the efficiency in kilometers per liter. So, what I have to do exactly is divide this number of kilometers by what? Well, by this number of liters. So let's see. Let's go ahead and write down what I'm saying. So we write down 48 2/5, and this is going to be divided by what? Well, by 5 1/2. 5 1/2. Look, we could do this operation by first converting to decimal and then doing the division. But I think it's harder if we do divisions with numbers that have decimal points. So in this case, what I'm going to do is work directly with fractions. Okay, that's what I'm going to do. And at the end, we'll do the division to see which decimal it corresponds to. All right, that's what I'll do. So let's go. So first, let's convert these mixed numbers to improper fractions. To convert this mixed number to an improper fraction, we'll do the following. I multiply the denominator by the whole number part and add the numerator. Look, 5 times 48 is 120. Wait, sorry, 240. And 240 plus 2. See, you add the numerator, so I get 242. 242. What is it? Fifths. Don't forget. Look, I did 5 times 48, which is 240, and 240. Then you add 2. That's why it ended up as 242. Okay, and that's going to be divided by 5 1/2. Same thing, we're going to convert it to an improper fraction. We do the same process. 2 times 5 is 10 plus 1. I get 11. 11. What is it? Halves? Okay, this is the operation I have to do now to solve it. Can we apply the rule of extremes and means here? It simply tells me that I have to multiply the two numbers that are at the ends, and I have to put that in the numerator. Then I'm going to multiply the two numbers that are in the middle, and we're going to put that in the denominator. So, let's go ahead and do the operations in the numerator. What do we get? Well, it would be 242 times 2. Right? Those are the two numbers at the ends. I'm going to leave it just like that, okay? And now we'll do the operations. 242 times 2. And in the denominator, I'll have 5 times 11, right? All right, I've already multiplied the extremes and the means. Okay, now let's do the two operations. We have 242 times 2 over 5 times 11. Look, I think this 242 can be divided by 11. Let me quickly do that division to see if it's possible. If it's possible, I can really simplify the operation. Before I do the multiplications, I still have left. Look, I'm going to see if I can divide 242. We're going to divide it by 11. Let me see if it's possible. Here, 11 goes into 24 2 times. 2 times 11 is 22, and 24 minus 22 is 2. I bring down the 211 goes into 22 2 times. 2 times 11 is 22, and 22 minus 22 is 0. Yes, you can. I mean, you can divide 242 directly by 11. Why am I doing this? Because look, this 242, what do you think if instead of writing it as 242, I write it as 22 times 11, it's still 242, right? That's what I'm going to do. So we write 22 times 11, which I insist is 242. And this is multiplied by 2. Why am I doing this? Well, because I already saw that we also have an 11 below. And I know that 11 divided by 11 is 1. Therefore, I could, sorry, I'll put it in quotes, cancel the 11s. So in the numerator, I'm left with only 22 times 2, which is equal to 44. And in the denominator, we have 5. And this division is pretty simple now, right? 44 divided by 5. Let's see, if it were 44 divided by 10, what would you get? Well, you'd get 0.4. But it's just divided by 5. So, the answer has to be 0.8. Do we agree on that? So 44 divided by 5 gives me 0.8. This one right here, then will be the solution. Anyway, I'm going to do the division. Just in case someone says they didn't know why the answer came out like that. We'll divide. Don't worry. Let's see. I'll do it over here. So let's do it then. 44 divided by 5. 5 goes into 44 8 times. 8 times 5 is 40. To get to 44, that's 4 left over. We bring down a 0, put a decimal point. 5 goes into 48 times. 8 times 5 is 40. To get to 40, that's 0 left over. Look, I'm getting that 44 divided by 5 equals 8.8. Therefore, the correct answer would be option A, right? So we select this one as the correct option. That's it. Let's move on to exercise number 43, which says, when expanding the binomial x plus y to the fourth power, you get, and well, they give us an expansion. And they're asking us for the values of a, b, and c. They also give us 4 possible answer choices. Look, this can be calculated quickly by remembering Pascal's triangle. If you don't remember what Pascal's triangle is, let me remind you briefly. Pascal's triangle is literally a triangle. We have to start by putting a 1, and then, in the next row, we're going to put 2 ones spaced apart, in such a way that a little gap is left here. Okay, then again, we're going to put another one on the outside, and in between these 2 ones, but in the next row, we're going to put the sum of these 2 numbers. 1 plus 1 equals 2. So here we put the 2. Then, again, we put a 1. You always have to put ones on the edges, okay? So, again, I move down a little to the next row. I put a 1, and here in the middle, I'm going to put the sum of these 2. 1 plus 2 equals 3, we do the same. 2 plus 1 equals 3. And again, I move down a little and put a 1. You're following me now, right? Let's see. Again, we put a 1 here. We're going to put 1 plus 3, which is 4. So here goes a 4. So start thinking about what goes here, which will be 3 plus 3. Right? That's 6. And here it would be 3 plus 1, which is 4. All right. Finally, we put another 1. Now, before moving on, start thinking, what numbers am I going to put? First, what do I put here? Very good. A 1. What do I put here? Very good. 1 plus 4, which is 5. Then, what do I put here? What number is it? Think carefully. A 10. Let's continue. Then, what goes here? Well, also a 10, right? And finally, well, almost finally, here we have a 5. And now, finally, a 1. Well, I could continue, obviously, but it's not necessary to put so many anymore. As I was saying, it's not necessary to put so many, because we already have enough information to solve the problem. Look, let me briefly tell you what this is about. Here we have a 1 and a 1 over here. We have a 1a, 2, and a 1. These here are so that we can solve, and well, so that we can know the coefficients of binomials raised to any power. For example, if we have an a plus b to the 1, it means that the expansion of a plus b to the 1 would be, then, 1 which is this coefficient, times a, then I'm going to put plus 1 which is this coefficient times b. This here, sorry, let me put it in red. This here. Well, it sounds pretty logical, right? So, it would be 1 times a plus 1 times b. It's really easy to understand. But now, look a little further ahead. What if, for example, we had a plus b, but squared? I want you to see, here I was putting it to the power of 1 here. I'm going to put it to the power of 2. Look, what I'm going to do, so I don't have to keep changing colors, is write the coefficients. So I write the coefficients, which are these I have here, which is a 1 I leave a little space, write a 2, and then write a 1. I'm writing these 3 numbers that I'm getting. Okay, now I'm going to write here. First, raised to the second power, so I write a squared. In the next one, I write AA, and in the next one, I don't write A anymore. Now, regarding B, I'm going to start from the right side, writing B squared, then I move over here. I write B, and here I don't write anything about B anymore. Finally, let's put plus signs here in the middle. What I'm saying here is that the expansion of the binomial squared gives me 1a squared plus 2ab plus b squared, well, plus 1b squared. I'm sure that sounds familiar to you, right? When we expand a binomial squared, that's exactly what we do. First, we square the first term, then add twice the product of the first and second terms, and finally add the square of the second term. So in that way, we could solve any exercise involving a binomial squared. With that little formula, let me do one more so you can see what I mean by everything I'm saying. Look again. Let's now, for example, do the following, which would be, now for the binomial cubed. So we write a plus b raised to the third power. We put the equals sign, and again, let's write the coefficients, which is a 1, I leave a small space, then it's a 3, I leave a space, then it's a 3, and finally a 1, right? All right, let's start now by writing a to the power. So now it would be a to the third, and we're going to decrease the exponent, okay? So it would be first a cubed, then a squared, then a, and then there's no a on the right side. We start with b to the third, that is b cubed, then here it would be b squared, then here it would be b, and here there's no b. So, as you can see, all that's left is to add the plus signs, and that's it. So now, the expansion of the binomial cubed would be a cubed, plus 3a squared b, plus 3ab squared, and plus b cubed. That's it. So, why am I saying all this? Because if you notice, Pascal's triangle helps me quickly find the coefficients. In this case then, what are the coefficients? Well, they are 1, 4, 6, 4, and 1. So look, here, I was already around here, right? I'm going to use red so it's a bit more noticeable. Here is a 1, which is this one here. Next comes the a, which in this case, a is going to be 4. Where should I put it? Put it down here. It's going to be 4, next comes b, which is going to be 6. Let me put it here. Next comes this 4, which is going to be c. And finally, there's a 1, right? That would be this one, since it's 1y to the fourth, right? If you notice, then, basically, I just needed to know about Pascal's triangle to be able to find the solution to this exercise. So the answer in this case is that a is 4, b is 6, and c is 4. Where is that? A is 4, let me change the color while you look for it. A 4, no, not this one. Here it is, right? A is 4, b is 6, and c is 4 done. This one here is the solution, so we circle option B. Done. We're finished. Simple, right? Well, this is important, so make sure you write it down anyway, because as you can see, well, it's not just useful specifically for solving this exercise, but what I just said helps us solve even a binomial to the fifth power. Which one would we use for that? Well, the next one, right? I mean, with this one I have here, right? Okay, let's continue. Exercise number 44, it says, what is the factorization of the trinomial?
X cuadrada menos 11x más 30.
We have 4 possible answer choices. Again, okay, look. In order to factor this trinomial, first it's absolutely necessary for you to look at its form. This trinomial has the form x squared plus bx plus c. That's its form, and to factor a trinomial with that form, we're going to do the following. You're going to open and close a pair of parentheses, okay? And at the beginning of the parentheses, you're going to put the square root of x squared, which is x. We put it there, okay? Now, we're going to look for 2 numbers. Pay attention here, that when multiplied give 30, but when added give negative 11. Start thinking about that. What are the 2 numbers? If I multiply them, I get 30 positive, but if I add them, I get negative 11. So it would be negative 6 and negative 5, right? I'll write them down and tell you again so you can check they're correct. Let's see. If I do minus 6 times minus 5, I do get plus 30. And if I do 6 minus 5, I do get negative 11. And guess what? We're done. That's it. The factorization would then be x minus 6 times x minus 5. Or the other way, x minus 5 times x minus 6. Well, here it is. Look, x minus 5 times x minus 6, which is exactly this. Remember that here, the order of the factors doesn't affect the product. Correct answer then, option D. There you go. Easy, right? All right, let's continue. Let's move on to exercise number 45. It says, starting from the equation, 3x squared equals 2x plus 5, find the values of x. It mentions the values because it's a quadratic equation, so there can be up to 2 different solutions. All right, let's solve it. The first thing I'm going to do is move this 2x to the left side by subtracting it, and also move this 5 to the left side by subtracting it. So, I'll bring down the 3x squared. We'll add this minus 2x, and the plus 5 will jump over as a negative 5. On the right side, we already have a 0. This equation can be solved using the quadratic formula, or we could also solve it by factoring. In this case, I'm going to solve it by factoring, and I'll use a factoring method called the cross method. This is very simple. It goes like this. We're going to break down the 3x squared as the product of 2 factors. In other words, what times what gives me 3x squared? Well, it could be 3x times x, right? And we're going to write that down below. Look, 3x times x already gives me 3x squared. Now I'm going to do something very similar, but with the negative 5. What times what gives me negative 5? Well, it could be, for example, negative 5 times 1, right? And you also write that down below. Now let's draw the x, which is something like this, and then we're going to solve the operation that's left for me. When we cross, all right, we do 3x times 1 equals 3x, then x times negative 5 equals negative 5x. This operation has to be done. So, I do negative 5x plus 3x. That gives me minus 2x. If the number I get here is the same as what I have here in the middle, does that mean the decomposition I did was correct? In this case, yes, I got the same thing. But keep in mind, since this involves trial and error, it may not work the first time, so I make small adjustments. For example, I could have put a 1 here and a negative 5 there, and it wouldn't have worked. So I would realize that I needed to make a small adjustment. In this case, fortunately, it worked out the first time, so the factorization will be as follows. Are you going to write it for me, but aligned? I mean, we're going to put 3x minus 5 in parentheses. Let me write it down. 3x minus 5. We open another parenthesis and put the x plus 1x plus 1. What I just did here is factor this trinomial that we had over here on the right side, so now we do have a 0. So have I already factored it? Once it's factored, it's really simple, because the next step is to set each of these factors equal to 0 and solve for x. So let's do it. We set them equal to 0. So the first factor, 3x, 5 is equal to 0. And from here, we solve for x. I'm going to do it right here in front. So I get 3x equals what? Well, this negative 5 goes over as plus 5. So here I get that x is equal to 5 divided by 3, right? Look, this 3 went over dividing. So now we have a first value for x. X is equal to 5 over 3. Now from here, we're also going to set it equal to 0 to find another value for x. So I get x plus 1 equals 0. We solve for x here, and then we get that x is equal to minus 1. The reason is because that one was being added, and we're moving it to the other side as a subtraction, right? So, now we also have the solution for the other value of x. Well, this would be x sub 1, and this would be x sub 2. Or the other way around, it doesn't matter. Let's see. So I have that x sub 1 is equal to 5 over 3, and x sub 2 is equal to minus 1. Which one is this? It's D, right? Let's see. 5 over 3, and minus 1. That's it, right? The answer then, in this case, will be in option D. We're done. Now let's move on to the next exercise, which is number 46. It says, the solution to the equation, they give us the equation here, is, and we also have 4 possible answer choices. Many times people get a little scared by this because they say, oh, there are fractions. But don't worry, okay? I mean, the fact that there are fractions really isn't bad at all. We're really going to solve it as if there were no fractions. Look, let me rewrite this equation, because I'm going to do a little operation that will actually get rid of the fractions. Look, I'm going to multiply the whole equation. Let me put it like this right away, because I'm going to multiply both the left side and the right side of the equality, that is, of the equation, by the least common multiple of the denominators. What is the least common multiple between 4 and 2? That is, if you are counting by twos, you would go 2, 4, 6, 8, 10, 12, and so on, right? And if you are counting by fours, you would go 4, 8, 12, 16, and so on, right? So what is the first number where they match? Well, it's 4. Why? Because you go 2, 4, 6, 8, and in the other one you go 4, 8, 12. So the first time they match is at 4. That's the least common multiple. So I'm going to multiply both sides of the equation by that least common multiple. Again, in this case, it's 4. Here's a quick comment. I think it's something I really need to say. If you say, "Wow, that topic was hard for me," or "the teacher said something I didn't understand," I recommend you do this. For example, if you don't know how to calculate the least common multiple, just type least common multiple here on YouTube, Grajeda, and you'll get a video. If you say, "I don't know how to solve equations," then type linear equations, Grajeda. Okay, what for? Well, so that you can practice and not just stick to the solutions in the guide. It's absolutely necessary for you to master each topic well, not just know how to solve the guide. Okay, let's continue. So now, let's multiply both sides by 4. Look, here I get 4. 4. By x, I'm multiplying by x. 4 times x is 4x divided by 4, so I'm left with just x. It's as if the 4 and the 4 cancel each other out. And I say cancel in quotes, because what really happens is that the division gives 1. And 1 times x, well, I'm left with x, right? Let's continue. Now I do 4 times 1. 4 times 1 equals 4. And on the right side, we have 4 times x. 4x divided by 2. So that's 2x. All right. Now this plus x, let me move it to the left side. So sorry, to the right side. Therefore, on the left side, we still have the 4. On the right side, we still have the 2x and this plus x. I'm going to move it as minus x. On the left side, we still have 4, and on the right side, we have 2x minus x, which equals x. Well, now we know that if 4 equals x, then that means x equals 4, right? So now we have the solution. X equals 4. Therefore, we select option C. There, we finished this other simple exercise as well, right? All right, let's move on to exercise number 47. Solve the following inequality. Well, here in these UNAM guides, I think there's a widespread mistake. They're saying that these are inequalities. Let's see. It's not entirely wrong, but it's actually better to say that this is an inequation, so I'm going to write it here so you can correct it. Is this really an equation? Look, it would be an inequality if I have, for example, 5 less than 8. This is an inequality, but when it already has x, that's actually an inequation. Okay? So that's much more specific. You can call it an equation, and equations are going to be solved. Okay, so let's solve the equation. This can be solved in 2 steps, just like an equation. Look, let's do it as if it were an equation. I'm going to put the x's on the left side. I'm going to leave them on the left side. I think it's easier for you that way. And whatever doesn't have x, I'll leave it on the right side. So I'll leave the 5x on the left side, and this 6x, let me move it to the left side as a subtraction. Okay, on the left side. Now on the right side, we had a -8 and this plus 3. I'm going to move it as -3. I'm just moving this over, right? Is that okay? Here I have 5x minus 6x. Let me write it as -1x. We put the less than or equal sign, and on the right side, we have -8 minus 3, which is a total of -11. Now, inequalities can be solved almost the same way as equations, when they're linear. Okay, but there's a small difference. When we multiply or divide by a negative, see, here there's a negative that I'm going to divide by. Well, when we do that, sorry, we have to flip the inequality. Be careful, when we multiply or divide by a negative, we flip the inequality. So in this case, I'm going to have to flip the inequality. Why? Because I'm going to divide by this negative number. So let's do it. I've already flipped the inequality anyway. So I get -11 divided by what? Divided by -1. And now, so, we have that x is greater than or equal to negative. Divided by negative, that's positive. 11 divided by 1 is 11. So the solution is that x is greater than or equal to 11. I don't know why a little line was put here. Well, x is greater than or equal to 11. Which one would that be? Well, that's option B, right? X greater than or equal to 11. Yes, that's it. This right here is already the solution. Done. Easy, right? All right, let's continue. Let's go with exercise number 48, which says, buying 3 kilograms of oranges and 2 kilograms of apples cost 42. If you buy 1 kilogram of oranges and 3 kilograms of apples, you pay 49. How much does a kilogram of oranges cost? Okay, this is definitely a system of equations, right? I'm going to say that the kilogram of oranges, that the price of oranges will be represented by the letter N. So, I'm going to say that N is the price of oranges. Specifically, I'm going to write the price of a kilogram of oranges. Okay, and I'm going to say that capital M, that's how I'm going to write it. It's the price of a kilogram of apples. Or, well, of apples. And now, with this information, with what I just wrote here, we can now set up our system of equations. When buying 3 kilograms of oranges and 2 kilograms of apples, you paid 42. So, what I'm going to do is put 3 times the price of a kilogram of oranges, which would be N, right? So I'm going to write 3N. Look, I'm putting 3 kilograms times the price of a kilogram of oranges. That's why I write 3N. Then, plus 2 kilograms of apples. So I'm going to write 2 times what? Well, times the price of a kilogram of apples. Well, when I buy this, I'm spending. In total, it says 42. So let's write a 42. Then it says, if you buy a kilogram of oranges, so I'm going to write an N. So 1 kilogram of oranges plus 3 kilograms of apples. 3 apples in total, you pay 49. All right. Now we have our system of equations set up. Is it asking you for the price of a kilo of oranges? So we want to know the value of N, right? All right then, let's solve it. Look, since I want to calculate N, then should I eliminate the N's? In this case, I'm going to use the reduction method, also known as the addition-subtraction method, because I think it's simpler. To be able to do this, I'm going to multiply both sides of the first equation by 3. I'll tell you why in a moment. And I'm going to multiply both sides of the second equation by 2. Let's see. The reason I'm going to do this is because when I multiply here, I'll get 6m. And when I multiply here, I'll get 6m. So, I'm doing that. So I end up with 6m and also 6m, and then I can subtract the m's. If I subtract the m's, m, as in Mary. Okay, if I subtract them, then I'll end up with 0m. Therefore, now I can solve for n. Let me do it so that, if you didn't understand, you can follow along with this. Look, so here I would have 3 times 3n is a total of 9n. Then we have plus 3 times 2m, which is 6m. That's equal to 3 times 42. That's 126, right? 126. Now we do something very similar, but with the second equation, and we have to multiply the entire second equation by 2. Okay, 2 times 1n, that's 2n, then plus 2 times 3m, that's 6m, and on the right side, we have 2 times 49, which is 98. Right? All right. Now look, I'm going to subtract these two equations. I insist, what I'm going to do is a subtraction, because what I want is to eliminate the Ms. y, so that I'm left with only n, you see. That's why I'm doing this here. So let's go. We subtract 9n minus 2n, that leaves me with 7n. Now what happens to the m's? Well, they cancel out, right? Because we have 6m minus 6m, and on the right side, we have 126 minus 98. I do the subtraction. It becomes 16 minus 8. I get 8. It becomes 11. Well, right away, it becomes 11 minus 9. I get 2. So, I end up with 126 minus 98. That's 28. And this is equal to 7n now. So this n is going to be equal to what? Well, to 28. And we're going to divide by 7. From here we get that n is 28 divided by 7, which is equal to 4. And what was it? N? It was the price per kilogram of oranges, right? So that's what I'm answering. How much does a kilo of oranges cost? It's telling me that it costs 4 R. So the correct answer will be the one in option D. Done. We're finished. That's it. Let's move on to exercise number 49. This exercise is the longest one in this guide because we have to set up the whole system using Cramer's rule. And that, well, it does take a little bit of time, okay? Here, again, I'm going to be saying a lot of things that might be a little unclear, but also understand that I can't explain everything from scratch in detail. So if you say, oh, I didn't really understand that part about Cramer's rule, please type Cramer's rule Grajeda and you'll find the detailed video. And not just one video, but several that explain Cramer's rule from scratch. So, it really is important that if something isn't clear to you, sorry, please do look it up, okay? Let's go ahead now and solve this system of equations using Cramer's rule. Look, the first thing we're going to do is find something called the system determinant, and it's going to be represented by the letter delta, which is this one, like a little triangle. Let's say, okay, well, in the problem, it's telling you to solve the system shown using Cramer's rule. Are they asking you what the value of c is? So, in order to do it, I absolutely have to do all of the following. Look, I'm going to put a little line here, and we're going to write the coefficients of our unknowns. So, I'm going to write the 2. Even if it doesn't show up, there's a -1 and the 3. So I put that down. 2, -1, and 3. They're the coefficients of these. Okay, for the letters, I also write the coefficients here. 5, 3, and -1. 5, 3, and -1, which are these. And finally, I write the coefficients, which would be 1, -3, and -4. Okay, so that's the first thing we have to do. 1, -3, and -4. Now, we're going to repeat these first 2 rows, so let's go ahead and repeat them. 2, -1, and 3. I've already repeated the first one. Now I repeat the second one. 5, 3, and -1. Well, let me make the line a little longer, and here we're also going to draw a line. All right. Now, to be able to calculate the determinant, which ended up too high, right? Let me lower it a little. So this was delta. Okay, that's called the system determinant. Remember, what we're going to do is multiply along the diagonals. Look, let's do it like this. Let me just change the type of line I'm going to use so you can clearly see what I mean. Look, we're going to multiply these numbers downwards like this. It came out a little crooked, but we're going to multiply downwards like this. Also these ones downwards like this, diagonally, and also these ones downwards like this. All right. Let's do those multiplications. Let me switch back to my original ink. There we go. So let's multiply, and remember, just like I have them, diagonally downwards. 2 times 3 is 6. Times -4 is -24. We write it down, and we do the same with these. 5 times -3 is -15, and times 3 is -45. So we write it down. Then it would be 1 times -1 is -1, times -1 is +1. We write it down, then we're going to put a minus. We open parentheses, and now we're going to multiply the numbers, but also diagonally upwards. So, I'm going to multiply like this. Look at these. Then I'm also going to multiply these diagonally, and I'm also going to multiply these diagonally. Okay, that's what I have to do. It turned out a bit crooked. Let's see if it looks better. I can't get it perfect, but there it is. The thing is, you need to see that we have to multiply them diagonally upwards. Okay, well now it looks better. Let's go. Let's multiply. So 1 times 3 is 3. Times 3 is 9. Then 2 times -3 is -6. Times -1 is +6, right? If I made a mistake somewhere, just let me know, please, okay? Put it in the comments. We're doing well. So, 5 times -1 is negative. 5 times -4 equals +20. As far as I know, I have the operations right. But if not, we'll correct it right now. We have to get to one of the answers. Anyway, let's go ahead and do this operation. That's all that's left. I have negative 24, negative 45 plus 1. Let's see. It's better for me to do this one first. Negative 45 plus 1 is negative 44. And negative 44 minus 24 is negative 68. Yes, negative 68. Then it's negative, and we solve what's here. Inside the parentheses, 20 plus 6 is 26, and 26 plus 9 is 35. No, 35. Let me check if I made a mistake, so let me quickly do that addition, because it's an addition of negative numbers, right? Let's see. Let's do this addition. Here I get 13 carry 1, and here I get 6, 7, 10, right? So I'm getting that minus 68. Minus 35 is minus 103. We're going to need this value now. Let me just erase that. I thought I was going to erase it. There it is. Just a moment. I'm going to quickly check if it makes sense that I got a minus 103. This value I just found is going to be the denominator of the resulting fraction. I'll show it to you clearly in a moment. Let's see. In this case, check if there's a minus 103 here. Yes, there's a minus 103. And yes, there's a minus 103. So, right off the bat, I'm telling you, these two are not going to be the answer. Okay, because they have a 101 at the bottom. So the answer is going to be either A or D. Okay? So let's go. All right, let's continue. I'm going to draw some more lines again, because now I'm going to calculate another determinant. The other one is simpler, simply because it has zeros. You'll see it in a moment. So now I'm going to calculate the determinant of C, okay? To be able to calculate the determinant of C, we're going to do the following. Look, we're going to use the same coefficient for A, the same coefficient for B, but instead of putting the coefficient for C, since I want to calculate C, we're going to put the value that's on the right side of the equation, which in this case is 2. So basically, what I'm going to do is leave this same column, but this one is going to change. Why? Because of the values that are here, that's what we have to do. So, look, it would be 2 and minus 1. Let me write it down. 2 and minus 1. And here, instead of putting 3, I put this minus 2. That's how it should look. Now for the next one, it's the same. I'm going to put 5 and 3, but instead of putting 1, I'm going to have to put what's on the right side. Imagine that I'm going to replace the C column with what we have. Let's call it the answer. That is, what's on the right side. All right then, let's put the 5. All right, let me put it correctly in its row, because right now we're going to have to operate 5, 3, and instead of putting negative 1, I would put 0. You're following me now, right? Let's see, in the next one it would have to be 1 and minus 3. Are those going to stay? And instead of putting the value of C, or, well, the coefficient of C, sorry, I'm going to put 5, right? So would it be like this? Look, here is 1, which is this one, minus 3, which is this one, and instead of putting minus 4, I put 5. Okay, that's what we have to do. And well, we agreed that the first 2 rows have to be repeated. The reason they have to be repeated is because we have to multiply all the numbers going down and all the numbers going up. So, let's do it again. Let's do the operations first. So we're going to multiply downwards. So let me select here with yellow so it looks nice. So let's do that multiplication. Let's do this multiplication too, and also this other multiplication. These 3, right? Come on, let's do them. 5, 2 times 3, 6 times 530. Then 5 times negative 3 is negative 15. And times minus 2 is plus 30. Remember, if I make a mistake, correct me. 1 times negative 1. Negative 1 times 0, 0. It's easier, as I was saying, because there's a 0. Then it would be minus, and we do the cross operations too, but upwards. So it would be these 3, then also these 3, and also these 3 here. There it is. These are the ones we have to multiply. So I have 1 times 3, 3 times minus 2. That's negative 6. Then 2 times negative, 3 times 0. Well, that's going to be 0. I'm going to put 0 right away. And 5 times minus 1, that's negative. 5 times 5, that's minus 25. minus 25. And that's it. Now let's do the additions, or, well, subtractions, or whatever is left. 30 plus 0, that's 60. Minus, well, I'm going to open parentheses, and here we have minus 6 plus 0, minus 25. This is minus 31, right? We continue here. Minus times, minus becomes plus, so I get 60. Plus 31, and 60 plus 31 is 91. If there's a 91, oh yes, there is a 91. So now we have both delta, that is, the main determinant, and the determinant of C. Well, what we have to do is the following. Look, I'm going to show you here in red so you can see it clearly. C has to be calculated by dividing the determinant of C by the determinant of the system or the main determinant. So come on, let's do that division. The determinant of C, I got 91. And that is then divided by the main determinant, which I got as minus 103. And well, plus divided by minus is minus, so I'm getting 91 over 103. So, is this here already the solution? Okay, which one is that? It's option D, right? Minus 91 over 103. Okay, got it. I mentioned to you earlier that this exercise was going to take a little while, and as you could see, it really did, right? But I hope it was understood, because I tried to explain it slowly so it would be clear. All right, let's move on to exercise number 50. This exercise says, what is the domain of y equals x squared plus 7x minus 1 over x minus 1? Let's see. Briefly, just so it's clear, the domain refers to the interval of values that x can actually take in a function. So here we have the function. Start thinking. What is that interval of values? What values can x take? Look, you can, for example, just by looking at the numerator, you can plug in a 5 here, right? There's nothing stopping you because it would be 5 squared plus 7 times 5 minus 1 that would give you a value. Okay, just considering the numerator. But if I look at the denominator, there's a specific value I can't use. Which one is it? What's the value I can't use? Well, it's 1. Why can't I use 1? Because if I plug in a 1 for x, will I get something? I don't care what the result is, but I'll get something over 1 minus 1, and 1 minus 1 is 0. So I'd have a division by 0, and we can't divide by 0, right? So x can take any value except that one. Okay, it can't take 1. Therefore, the domain is that x is not equal to 1. That means it's all the numbers except that one. Well, the way we're going to represent it, because notice that it's not exactly as I'm saying it, which would already be the domain. Okay, but it's represented differently. So let me explain how we have to arrive at one of these answers. It's pretty simple. Look, if you start thinking about a graph, thinking about something like this, you start walking from the left to the right. But when you get to one, you can't take it. So you keep walking, but without taking the one. Let's suppose you're walking, the domain up to infinity. So first you would start walking, right? No. But
¿Quién? Pues hasta el 1. Pero,
the domain is from minus infinity.
entonces yo estoy diciendo que
Which ones? Infinity. And I go up to 1 without touching 1. That's why I put a parenthesis. Then I'm going to join this. And now I start walking again from 1, and I keep walking until where? Well, until infinity. And that's it. This one here. That would be the representation of the domain of this exercise. And which one is that? Let's see. From minus infinity to 1, which is this one, it doesn't seem right to me. Let's see. Minus infinity to 1 union 1 to infinity. So it would be option C. That's it. That would be the solution. I want you to notice that here, for example, there are some that look similar, but for example, option A might seem like the answer. But no. And why is that? No, because it has brackets. When you see brackets, does it mean you can take the value? In this case, we see, well, we can't use a 1, precisely because if we put a 1 into x, we have a division by 0, and we can't do that, right? So the correct answer would be option C. All right, let's move on. Now let's go to exercise number 51. In this case, are they asking you about the range? Let's see. Here we're going to do something very similar to what I just did. But now, instead of thinking about the x-axis, let's think about the y-axis. That is, about f of x. That's what we're going to be thinking about. Look, let's do it the following way. Because I don't want to get into very advanced things either. Because really, that can be done with limits. But I don't want us to look at the concept of limits. I want us to do it much more simply. Let's see. Start thinking. What is the value that I can't assign to x? When can't I assign a value to x? Well, I can't assign a 0, right? Because if I put 0, I'd get 0 squared plus 0. Pay attention to x. It's still 0 squared plus 0 divided by 2 times 0. So if I plug a 0 into x, I'd get 0 squared plus 0, which is 0, divided by 2 times 0, which is 0. And this is an indeterminate form. When we have an indeterminate form, what we're going to do is factor our function so we can find another function. But it should be, let's say, in quotes, equivalent to the one I have there. How can I find another function? Well, it's very simple. I can factor, for example, here in the numerator. This way, here I would have x. I open parentheses and say, what do I multiply x by to get x squared? Well, by x plus. What do I multiply x by to get x? By 1. Now, in the denominator, let's not forget that we had a 2x. Why am I doing this? Because if x is not equal to 0, since we already saw that it can't be 0, right? Can I cancel this one and this one? Okay, careful. I'm thinking here that x can't be 0, all right. So let's continue. And in the numerator, I'm only left with x plus 1. And in the denominator, I'm left with 2. Okay, let's see. I already know it can't be 0. I already know that. It can't be 0. So I'm going to check what happens to y when x is 0 to see what value it can't take. Let me explain. I already know that x can't be 0. Okay, I already know it can't be 0. Now what I'm going to do is, in this new function I have here, I'm going to substitute a 0. Why? Well, so I can see what value it won't take. And just imagine I'm going to draw an ugly curve, and I'll erase it in a moment. Just imagine it would look something like this. For example, I have a curve, but I already know that x can't be 0. I'm going to put a little hole there, so I'm going to substitute a 0 to see what value it would have if x could be 0. Why? For what purpose? Well, so I can see what value it can't take. And for that reason, I'm going to substitute a 0 then. Okay, so let's do it. Sorry, a 0 here. If I substitute a 0, so if I evaluate this new function at 0, then I get 0 plus 1 over 2. So I get 1/2. All right. This here would be the value it can't take. And, okay, that 1/2, because that's the value when I'm plugging in x equals 0, which was the one it couldn't be. Okay, because if I put a 0 there, we'd have a division by 0, that's why it couldn't. So what I just did allows me to find the value of y the value it can't take. And therefore, the range is that set of values that it can take. And so it would have to be the following. It would have to be that y has to be different from what? Well, from the one it can't be, that is 1/2. Okay? Therefore, the range would be, once again, now we walk along y. And we have, so I'm going to draw a little graph here. Imagine it like this. More or less. Let me make the line a little nicer. Imagine that now we want to walk along y. It's like a staircase. So we start walking along y, we walk, we walk, we walk. But there's a little value we can't take, right? Which is exactly this one that's equal to 1/2. Let's continue.
Caminando y todo lo demás sí lo vamos a
Take, except for that 1/2, right? So I could start walking from negative infinity and go towards infinity. But I already know that I can't take 1/2. Therefore, how would the range look? Well, it would be to start walking from minus infinity first, comma, and try to reach what? 1/2, but I already know that I can't take 1/2. So I put a parenthesis, union. Where do I start? Well, again, 1/2. Careful, without touching 1/2, that's why I use a parenthesis. And where do I go? To infinity. So, the range would be from minus infinity to 1/2. Union from 1/2 to infinity. Which one is that? It would be from minus infinity to 1/2. Union. 1/2 to infinity, right? So the correct answer would be the one in option D. Look at the others. For example, here we have from minus infinity to minus 1/2. Here there was also. Well, this symbol that's upside down should have been the union. It should have been this one. This one here also has an interval without a union. But no, those there don't make sense. The only one that could be the answer is then option D. All right, we're done. Let's move on to exercise number 52. Sorry, it says, what is the result of the following operation? G of x, y, minus f of x. And that might seem hard, really hard, but the truth is, it's actually pretty simple. Basically what we have to do. Since they're already telling us what f of x, y is, and they're also telling me who f of x is, well, I just arrange it. Since it's here, then come on. We put g of x, y. What is this that's here? So I'm going to put 7x plus 5y. Minus 11, it says. Subtract from this. Subtract. I open a parenthesis. What is it? F of xy, which would be this right here, right? So, 2x minus 3y plus 5. That's it. Basically, we have a subtraction of polynomials here, right? Obviously, these are functions, okay, but as it stands, it's a subtraction of polynomials. For this, then, we're going to bring down the 7x plus 5y minus 11, and we're going to multiply these three terms by minus 1. Minus 2x would go here, then minus times plus. Sorry, minus times minus is plus, so that's 3y, and then minus times plus is minus, so that's 5. Let's continue. We look for like terms, the x's with the x's and the y's with the y's. 7x minus 2x, let me mark it here. 7x minus 2x. In total, I have 5x left, right? All right. I'll put it over here, then we go with the ones that have y, 5e plus 3i. In total, I have 80 left. And finally, let's go with the ones that don't have either x or y. Here, we have a minus 11 and a minus 5 that gives me minus 16. So this would have to be the solution then. Well, let me change the color because I've been marking with green, right? Ah, well, you can kind of see it there. There it is. So the solution is 5x plus 8. Sorry, I missed the y here. 80, let me put it in blue, minus 16. Where is that? 5x plus 8i minus 16, is it this one? So, the correct answer is option B. We mark it. There it is. It's ready. It says, convert the value of an angle that measures 2/4 of pi radians to degrees. That one is answered in seconds. Okay, let's see. 2/4 of pi radians, we simplify the 2/4 that's equal to 1/2, right? 1/2 pi radians. We don't know what this is equal to, so I'm going to call it x for now. What we do know is that 360 degrees, sorry, I'm writing it over here, backwards. 360 degrees is equal to 2 pi radians. 2 pi radians. This can be done logically, right? Because look, 360 degrees is equal to 2 pi radians. Or in other words, 2 pi radians is equal to 360 degrees. And here we could keep having it. Right, because I want this. I mean, I want half of pi radians. So, let's see. If we take, for example, half here and also half here, how would that look? Well, half of 2 pi radians would just be pi radians, right? So how much would pi radians be? Well, half of 360, which is 180 degrees. Right? Now I don't want pi radians, I want half of pi radians. Well, if pi radians is 180 degrees, then half of pi radians would be how much? 90 degrees? I was setting it up like that because I wanted to do a proportion, but it doesn't make sense, does it? Well, there's no point in doing it because it's pretty simple. I mean, they're really telling me, look, if you already know that 360 degrees is 2 pi radians, then how much is half of pi radians? Well, it would be 1/4 of that, right? I mean, 1/4 of 2 pi radians would be half pi radians, right? And if not, then you do this whole process that I'm showing you here. And if not, then just use a proportion. What you really have to remember is that 2 pi radians are 360 degrees. That's what you really need to remember. All right. So the correct answer was that 1/2 of pi radians is 90 degrees. So the solution is option B in this case. Well, it's in the option. All right, let's move on. Exercise 54 says, based on the following image, determine the trigonometric ratio that corresponds to the secant of angle theta. Let's see. Here, to be able to solve this, I think it's necessary for you to at least remember how the trigonometric ratios are arranged, so that you can learn them. Look, I recommend that you learn them like this. Sine, cosine, tangent. Then you're going to put cotangent, then secant, and finally cosecant. It even has a little rhythm. Look, sine, cosine, tangent, cotangent, secant, cosecant. Again, sine, cosine, tangent, cotangent, secant, cosecant. Once you have them arranged like this, we're going to put any angle here. For example, theta. And now, so you can know what each one of them is equal to, you're going to do the following. Look, it might end up a little crowded, but let's see if I can fit it in well. I probably should have spaced them out more, but you get the idea. Let's make up. Well, not make up. Let's remember a chant. The chant goes like this. Op, adj, hip, hip, op, adj, hip, hip. That's it. Remember that, please, for your exam. Op, adj, hype, op, adj, hype. We're going to put that here. Op, adj, first in the numerators. Op, adj, again. Op, adj, and hip, hip, right, hip, hip. So we do coca, hip, hip. Now we do the same, but from bottom to top. Again then, op, adj, again, op, adj, and hip, 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 hip. What do you think? We already have all the trigonometric ratios. Look, the sine of theta is opposite side over hypotenuse. That's right, isn't it? Cosine of theta is adjacent side over hypotenuse. Tangent of theta is opposite side over adjacent side. Cotangent is adjacent side over opposite side. Secant is hypotenuse over adjacent side, and cosecant is hypotenuse over opposite side. That's all of them. So now, with this, now that we've remembered what they are, let's solve the exercise. They're asking you for the secant of angle theta, so I'm going to go here. So I want the secant of angle theta. Come on, what would it be? It says it's the hypotenuse. Which one is the hypotenuse in this case? Well, it would be this one, the biggest one, right? That is the square root of 13. And then that has to be divided by the adjacent leg. Which one for this angle theta? That's the adjacent leg. Sorry, because it's the one that's next to it. That would be the opposite one, right? So, the adjacent leg is 2. And that's the answer. So it's the square root of 13 over 2. So it would be option B. That's it, right? Done. We finished easily, right? If we learn it, it's simple like this. All right, let's go with exercise number 55. The domain D and the range R of the function f of x equals e to the x divided by minus 5r. This exercise might seem very difficult, but it's really not that hard, okay? Let me quickly draw a Cartesian plane. Well, it might not look that nice. Well, my line turned out really bad. Let me fix it. There it is. And well, I'll try to make it as good as possible. It's coming out really crooked here. There it is. I just wanted it to be aligned there with that line. There it is. So, come on, let's draw a Cartesian plane, because it's important for you to know a few things. For example, it's necessary for you to know the graph of the function f of x equals e to the x. F of x equals e to the x. It's a curve that looks more or less like this. So this is the graph of the function f of x equals e to the x. Now, in case we are multiplying or dividing e by some negative number, basically what it does is it will invert the equation. Sorry, the graph. So this graph, just imagine that it's going to be inverted. All right, I'm not too interested in what happens, but I already know that this one keeps going this way. I mean, up to negative infinity, but then it goes down this way. Okay, so this would be the graph of a function that has, for example, minus ae to the x. Okay, I'll put minus a, because, well, I'm not checking exactly where it's crossing, or how fast it's going down. I already know that multiplying or dividing by a negative number, like here, causes it to go downward. Does the graph matter now? if I already know that the graph is going downward? And we had already agreed on that the domain is all the values that x can take. So in the domain we're going to have from negative infinity to positive infinity, right? Because look, I'm going to continue the graph a little bit, and I want you to see that this part here keeps going. Keeps going. Let me change the color. This part here keeps going, keeps going, keeps going. I mean, in x, it will always keep going. Now over here, it's also always going to go down. So, since it's always going to keep going to the left, and it's also always going to go down, I mean, it's always going to go to the right as well. So really, does that mean that the domain would be from negative infinity to positive infinity, okay? So here we see that C could be the answer, and D could also be the answer, because both have plus and minus infinity. The most important and complicated part is the range. These two can't be it, since their domains are incorrect. The range is a bit more difficult and is what I want to focus on. Remember that for the range, we're going to look at the values the function can take, but seen from y in simple terms, obviously. So look, what's the smallest value it can take with respect to y? Well, negative infinity, right? I mean, really, this one comes from down here and keeps going up, 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 up. But what is it trying to reach? Does it try to reach 0? But it never touches 0, since I said this curve gets closer to the x-axis, but never actually touches it. So, actually, the range would have to go from negative infinity up to 0 without touching 0. For that reason, I use a parenthesis. So what should the answer be? Well, it goes from negative infinity to 0. It's this one right here, right? So the correct answer is the one in option D. So now we have that the domain is from negative infinity to positive infinity. For all exponential functions, it really is, okay? And the range goes from negative infinity up to 0 in this case. Look, this one might also seem like an answer, but it's not. Because it says it goes from 0 to infinity, but the range doesn't go from 0 to infinity. Why not? Because remember, it was going down. If they had asked us about one that had a positive sign here, a positive sign here, then this one right here would be the range from 0 to infinity. But since it was inverted, it went from negative infinity to 0. Okay, good. Let's move on then. So let's go with number 56. It says, calculate the distance between the points -1, 1, which would be P, and 1, -1 on the plane. In this case, we can do it in two different ways. Well, we can do it with the Pythagorean theorem, even though it might seem strange. We can do it with that, or we could do it with a formula. So, look, I'm going to show you both ways, even if it takes us a little longer. But it's important for you to have more than one option to solve your exercises. All right, I'm going to quickly draw a Cartesian plane here, and then we'll plot the points we're talking about. The problem says that point P is located at -1, 1. Let's suppose that each square is worth 1. Okay? So, -1 would be somewhere around here, right? -1, sorry. -1 up here. So, here's point P. Now point Q is at 1. -1, 1. -1 I'm getting in the way, but point Q is somewhere around here. All right. So, we need to find the distance between those 2 points. As you can see, it's simple. Why? Because a right triangle is being formed here, right? Look. Here we have a right triangle. If we leave it here and draw this way, there's a right triangle. And what I really want to know is the length of the hypotenuse. That's what I want to find out. It's simple then, isn't it? How long is it from here to here? Well, it's 2. From here to here, it's 2. And what is it that I don't know? I'm going to call this x, which is really the distance, right? So, according to the Pythagorean theorem, I'd have that x squared is equal to what? Well, 2 squared plus 2 squared. Remember that I have to add the squares of the legs, so I get that x squared is equal to 2 squared, which is 4 plus 2 squared, which is 4. Therefore, x squared is equal to 4 plus 4, which is 8. And well, from here we're going to take the square root of 8. So, what would I get? So, the answer is option A, right? That's it. This one right here is the answer. Done. We're finished. Simple, right? Look, I was telling you that you could also do it with another formula. That would be directly with a little formula. I'm going to show it to you here. The distance is going to be calculated by putting the square root of x2 minus x1 squared plus y2 minus y1 squared. This formula actually comes from the Pythagorean theorem. Okay, so let's see what x1 and y1 are, and who x2 and y2 are. Let's see, if this is your point 1, I mean, if p is point 1, then this would be x1 and this would be y1, because it's point 1. And if this is point 2, sorry, then this would be x2 and this would be y2. All right then, point 1 has coordinates x1, y1, and point 2 has coordinates x2, y2. And honestly, it doesn't matter which one you choose as point 1 and which one you choose as point 2. It makes no difference. So let's see. Let's just substitute then. So I have x2. What would x2 be? Well, the x from point 2, which is 1. We put minus x1. What is x1? The x from point 1, which is minus 1, I'm going to use double parentheses to separate the negatives. Here it says it's squared. Then plus y2, which is the y from point 2 minus 1. Minus y1, which is the y from point 1, which would be 1. Don't forget that here we have a minus sign because of the formula, and we raise it to the power of 2. Let's continue here. So I get the square root of, and here we have parentheses. 1 minus negative 1. 1 minus negative 1 is 2, so I get 2 squared plus, and here we have negative 1 minus 1, which is negative 2. And that's also squared. Let's continue here. So we have 2 squared, which is 4 plus negative. 2 squared, which is also 4. And well, let me move this a little. We'll move that. So I end up with the square root of 4 plus 4, that is, the square root of 8, right? Let's see. Here I drew the root really badly. Let me make it look nice. Square root of 8, there we go, all set. So the answer would be option A. We're checking it, right? Look, we're doing it in 2 different ways. If you ask me, I prefer to do it using the Pythagorean theorem. I think it's much simpler. Let's move on to the next exercise. Number 57. What is the slope of the line passing through these 2 points? They're giving us the points. Again, let's start by drawing a Cartesian plane, because I'm going to do it in 2 different ways as well. Let's see. It turned out a little messy there. I thought it was going to look fine. Ah, I remember now. I forgot that if I leave a little space here, it can move, right? No? That's true. Well, it's done now. Let's go. So, we have the 2 points, which would be 3, 2. So again, I'm going to say that here is 1, and here is 1, just to set the scale. Okay, so this is worth 1. We put 3, 2. 1, 2, 3, 2. Here will be point A. This is A, and 1, 5. 1, 1, 2, 3, 4, 5. And over here we have point B. Here we want to find the slope of the line that passes through these 2 points. Look, I'm going to show you something that's really cool. Right now, look. First, we're going to do it using a pretty simple method. Let me draw. I'll even change the color. I'm going to draw a right triangle. Let's see. It turned into a curve. It's a straight line up to there. And also up to here, I'm going to draw a right triangle, the one that just formed right there. And now, I'm going to put the measurement of the base of the right triangle that was formed, which is 2 units, right? And the measurement of the height, which is 3 units. Now, if the line is going down, look, this is going down, right? This is going up. Well, if the line, which is this one here, I mean, the one that passes through A and B, if the line is going down, it means the slope is negative. So in this case, the slope is going to be negative. And all you have to do is put the height of the triangle, which is 3, over the base of the triangle, which is 2. And guess what? We're done with the slope. So, will it be negative 3 over 2? That's all we have to do. So the answer will be negative 3 over 2. Where is that? Option D, right? Negative 3 over 2, we're done. So, would that be one way to solve it? There's another way to find the slope, which is directly with a little formula. I'll write it here for you as well. Look, the slope, that's it. If we don't want to do all that, we can calculate it with the following formula. We put y2 minus y1 over x2 minus x1. y2, y2. All right, let's substitute again. Who is x2? Well, x is from point number 2. Who is y1? Well, y is from point number 1 and so on. So I'm going to say that this is my point 1 and this is my point 2. All right, so let's go. I have y2. It would be 5 then, right? 5 minus y1, which would be 2 over x2, which would be 1, right? Minus x1, which is 3. We do the math. 5 minus 2 is 3 over. 1 minus 3 is minus 2. Positive over negative is negative, so this would be minus 3 halves. How can you tell? Well, we're arriving at exactly the same solution. The slope is minus 3 halves. That's it, right? Done. Simple. Let's move on with exercise number 58, which says, what is the equation? Equation of the line that passes through point P minus 5, 2, and is parallel to the line that passes through points Q and R. Well, okay, let's see. Here again it's going to be necessary that, more than making a perfect nice graph, it's important that you imagine the problem. So look, imagine it. I'm going to draw it really quickly now. Imagine that we have any line that passes through 2 points. Any 2 points, for example, this line that passes through this point and this point. It doesn't matter which ones they are. What I want is for you to get the idea. So I could find the equation of that line. Okay, but imagine that I don't want that equation. I want the equation of the line that passes through this point, which I'm marking in red, but that is parallel to this one in this case. So if I want to do that, then first I would have to find what is the slope of this line here, right? Why? Because the slope has to be the same as the one I have here, since it's saying that they have to be parallel. In other words, what will be preserved is the slope of these two lines. Therefore, since I don't have any data for point P, other than the fact that it passes through that point and that's it, or, well, for that line, what I'm going to do is find the slope of the line that passes through those 2 points. Because if I find the slope of the line that passes through those 2 points, then I'll also know the slope of the line that I want. Okay, why? Because it says they're parallel. And if they're parallel, again, it means they have the same inclination, that is, the same slope. Are you following me on that? So, come on, the first thing I'm going to do is calculate the slope. Of what? Well, of the line that passes through R and Q, right? Well, through Q and R, that's what we're going to do. So, come on, let's substitute. I'm not going to write the formula anymore. I imagine you've already memorized it, right? So, come on, we put y2, which is 3, and if not, well, write it down. Go back a bit and write it down. Minus y1, which was minus 6. I already put y2. Minus y1 over x2, which is minus 1. Minus x, 1, which is 2. Let's do the operations. Here, I would have 3 minus 6. I'm going to write it right away, 3 minus 6. Well, it would be 3 plus 6 and 3 plus 6. That's 9, right? And below, we have minus 1 minus 2, which in total is minus 3. Plus divided by minus is minus, and 9 divided by 3 is 3. Let's see. Now we have the slope. This is the slope of the line. Oh, well, there it is. That's the slope of the line that passes through Q and R. And that slope has to be the same as the one that passes through. Sorry, it has to be the same as the slope of the line that passes through point P. Right, because they're parallel. Therefore, the slope of the line that passes through P also has to be negative. And then, what follows is simply to remember the equation of the line in its slope-intercept form. That is, y equals mx plus b. Now let's see what we already have. We could already have m, which is minus 3, right? But we still need to calculate b. And how do we calculate b? Well, it's very simple. Let's consider this as x and this as y. Okay, and let's substitute it here. So now we already have y, which would be 2. We already have m, which we calculated with the other points, and we already have x, which would be 5. And could we solve for b so we can finally have the whole equation? All right, let's do it. So we put y, which is 2 equals m, which is minus 3. Let me put parentheses to group the negative, times x, which is 5, times 5, and plus b, which I don't know. Let's solve for b from here. So I have 2 equals minus 3 times 5, which is minus 15, plus b. And well, this minus 15 will be added. So I get 2 plus 15, right? And 2 plus 15 equals 17. So now we have the value of b. Let's see. I know how I'm going to do it. Let's do it like this. No, sorry. It was like this. And we wait and remove it. There it is. Now we also have b, right? Therefore, how is the equation going to look? Well, it's going to be y equals m, which is the slope of both of them. That is, minus 3 times x, which is the variable, plus b. But b is 17. And what do you think? We've finished the equation of the line that passes through the given point and is parallel to the line that passes through those 2 points. It's this one I have here. That is, y equals minus 3x plus 17. Tell me it's there. Yes, here it is. Look, y equals minus 3x plus 17. So we box in option D. Done. We're finished. Let's move on to exercise 59. Which of the following equations corresponds to a circle with its center at the origin and a radius of 2? That's actually pretty simple, because you just have to remember the equation of a circle. The circle, when its center is at the origin, it's x squared plus y squared minus r squared equals 0. That's the equation. R is the radius. So then, how would it look? So it would be x squared. Let me change the color. X squared plus y squared minus r squared, that is, the radius squared, which would be 2 squared, so 4 equals 0. That's it. There's nothing else to do. It's really a theoretical question, and that's it. So the solution would be this. Which one is that? X squared plus y squared minus 4, this, right? X squared plus y squared minus 4 equals 0. Yes, so the correct answer is the one in option A. Done. Simple, right? Let's move on. Exercise 60. Indicate the center and the radius of the circle x squared plus y squared equals 20. Like I was saying, this one here, well, again, let's remember it. Isn't it x squared plus y squared minus r squared equals 0? We can see it that way, but we can also move the r squared to the other side, right? X squared plus y squared equals r squared. This right here is the equation of a circle with its center at the origin. So, just by seeing that way, I already know that the center has to be at the origin. That is, at 0, 0. So, right here, right? So it could be this one, it could be this other one, but not these, because their centers are not at the origin. So these can't be it. Therefore, the answer is either A or D. Now, how do I figure out which one it is? Well, it's very simple. Notice that by comparing what I have here with what I have over here, you can see we have x squared, y squared, y squared. 20r squared. So that means that r squared equals 20. Let me write it down then. So r squared equals 20, right? What does this mean? Well, what would the radius be? It would be the square root of 20, right? If the radius squared is 20, then the radius is the square root of 20. So the solution would have to be this one over here. So we circle option D. Done. Why isn't it option A? Because what equals 20 is r squared, not r. So this one isn't correct. Even though its center is correct, the radius isn't correct. The radius is the square root of 20. All right, let's move on to exercise number 61. Calculate the vertex and the focus of the parabola with the equation x minus 1 squared equals 8 times the quantity y plus 3. Look, this one right here, well, as it says here, is a parabola. And one more thing, it's a vertical parabola. I'll write it here right away. It's a vertical parabola. We know it's a vertical parabola just by its shape. I need you to memorize what I'm about to write next. When you have a parabola that's vertical, the form will be like this. It's going to be x minus h squared equals 4p times y minus k. That's for when it's vertical. If it's horizontal, it's going to be y minus k squared. That is, this one is equal to 4p times x minus k. Look, so this one would go over here, and this one would go over here. in case it were horizontal. In this case, we know it's vertical simply because it has the x minus 1 here. Well, it has the x on this side, which is the one that's squared. Okay, so it's a vertical parabola. Now, where is the vertex of the parabola? Very simple. The vertex is at the coordinates h, k. And as you can see, we already know the values of h and k, right? Why am I telling you this? Because look, compare this equation with this form I have here. Notice, minus h is minus 1, right? So, if minus h is minus 1, what does that mean? Well, that h is 1. So let's say the vertex has coordinates 1, k. Let's see. Here we have y minus 3. Sorry, y plus 3. And here we have y minus k. So what does it mean that minus k is plus 3? So, if minus k is plus 3, that means plus k is minus 3, right? So let's put a minus 3 in place of k. Again, why? Because minus k is plus 3. And if minus k equals 3, then k will be minus 3. All right, now we have the coordinates of the vertex, so let's see which one it could be. Answer: 1, negative 3. Not this one. 1, negative 3. This one, yes. Negative 1, negative 3. Not this one, and 1, negative 3. Look then, it's between B and D. But we still need to find the focus, right? All right, let's go with the focus. To find the focus, let's pay attention to P. P is the distance from the vertex to the focus, from the vertex to the focus. So, come on, let's set this little part here equal to what? Well, to what's there in the corresponding position, right? I mean, I'm going to set 4P. Let me change the color again.
4P.
4P is equal to what? Well, to 8, right? That's what's in the same position now. If 4P equals 8, then I can solve for P here, right? This 4 will go to the denominator and, well, I'll have 8 divided by 4. And from here, we get that P equals 2. P. It's the distance, as I was saying, from the vertex to the focus. What does that mean? Well, that's starting from the vertex. 2 units up is where the focus is. 2 units up. So, if we already know, let me quickly draw the Cartesian plane here, even if it's brief. 1, negative 3. If we already know that the vertex is at 1, negative 3, which is going to be a little lower, right? Let me put it here at 1, negative 3. If we already know that the vertex is here, then the focus will be 2 units above the vertex. Why above? Because we said it was a vertical parabola. And since it's vertical, that means it opens upward or downward. In this case, it opens upward. Why do I know it's upward? Because P is positive. If P had been negative, then it would mean the parabola opens downward. But in this case, the parabola opens upward. That means the focus is 2 units above the vertex. So right here is where the focus will be. What are its coordinates? Well, its coordinates are 1, negative 1, right? 1, negative 1, Now if I wanted to make the graph, even just a little bit, I would have to do something like this, right? I mean upward. Always remember that the parabola will wrap around the focus, meaning the focus is inside the parabola. It doesn't go down here. Okay, good. So we're done. The focus has coordinates 1, negative 1. I covered it up a bit there. Focus, 1, negative 1. Here I have negative 1, negative 1. Oh, was it not this one? Sorry. I was thinking, what was this? I was starting to get worried. So, would it be option B, 1 minus 1? Not this one, because it says 1 minus 5. So, no, not this one anymore. Therefore, the correct answer, since this one matches the vertex and the focus, will be option B. All right, we're done. Look, another commercial. If you say, no, now the guide really got complicated, then start watching the videos that are about analytic geometry. Here on this channel, Matemáticas con Grajeda, I already have a complete playlist, but it's complete with more than 60 videos where I explain the entire analytic geometry course from scratch. So, really, if you feel like you didn't fully understand this part, go watch at least the topics, or, well, the videos about the parabola, so this can be much clearer for you. Okay, it's important that you review well. Let's move on to number 62. I think this is one of the hardest ones in the Analytic Geometry Guide. What are the center's coordinates? They wrote it lowercase, huh? Usually, we use uppercase. Of an ellipse whose equation is, well, here we have the equation of the ellipse. Look, let's write the equation of our ellipse here. The equation of the ellipse. It's like this. Look, we write x minus h squared, and in this case, we'll put it over b squared, plus over here, we write y minus k squared, and this over a squared. And this equals 1. All right, this is the equation, the ellipse. Okay, I'm not interested in it right now, at this moment, to be able to solve this exercise. Whether it's a horizontal ellipse or a vertical ellipse, that doesn't matter. For now, what really matters are the coordinates of the center. It says, well, for the ellipse, the center has coordinates.
H, K.
So, determine which is h and which is k. In this case, you can answer quickly. If we look at it this way, see which one is h. H is this right here, right? So, I'm saying that minus h equals minus 1. So, if minus h equals minus 1, what does that mean? Well, that h is 1. Therefore, let's put a 1 here. Now we already know that minus k is the one here next to the y, but what's here? Well, actually, there's a 0. It's as if it were y minus 0 squared or y plus 0 squared. So, what does it mean? K is 0, right? Because there's nothing here. So then here I'd have a 0 on this side, and that's it. That's all I have to do. The center has coordinates. Therefore, we circle option B. Let's go with exercise number 63, which says, what is the locus in the Cartesian plane, in which the absolute value of the difference of its distances to two fixed points? Well, I'm going to select that quickly. Fixed is constant, positive, and less than the distance between those fixed points. Let's see, when it talks about those fixed points, is it really referring to the foci? So, it's saying that there are two fixed points. I mean, it's saying that there are two foci. I'm telling you this because here we're going to start narrowing things down and see that some options can't be the answer. What they're giving you here is actually the definition of one of these four. They're literally giving you the definition. So you really need to know a little bit of everything, theory as well. All right, let's see. The circle? Let me ask you, when we talk about a circle, do we usually talk about foci? No, right? We talk about the center. So even though, in stricter terms, the circle actually does have two foci that are in the same position, in practical terms, when we talk about the circumference, we don't talk about foci. So it's not the circumference. Now, does the parabola have two foci? No, it has one focus, right? So, no, the ellipse has two foci. Yes, the ellipse does have two foci. The ellipse. Remember that it can be, for example, something like this. So it does have two foci, so ellipse, it could be now hyperbola. The hyperbola has two foci. Yes, it also has two foci. So, which one do you choose? Do you go with the ellipse or do you go with the hyperbola? Which of these two? Why could these two be a parabola? We agreed that they can't, right? Well, the correct answer is hyperbola. I was telling you that this, in fact, is the definition of a hyperbola. The definition of an ellipse is very different. It has nothing to do with that in the definition of an ellipse. It's more about adding distances. I mean, adding this plus this, and seeing that it's also the same as this plus this, and also seeing that it's the same as this plus this, and so on. So, when he talks about an ellipse, remember that it's really about the sum of distances to the fixed points, called foci. That's what the definition of an ellipse is about. And the definition of a hyperbola, as you can see, is different. So in this case, the correct answer would be hyperbola. All right, let's move on. Last question, it says, what type of conic does the equation represent? Y squared plus 4, x plus 2x plus 16. Sorry, plus 2 plus 16 equals 0. Let's see. I want you to look at a few things here, because we're going to start to rule things out. Parabola with vertex at the origin? No. Why do we know it's not a parabola with vertex at the origin? Simply because of its form. In the case of the parabola, the shape could be like this. Y equals 4px.
px.
It could be like this, or it could be like this. X squared equals 4py. As you can see, for example, x and y do not appear together here. Instead, y squared appears and x appears. This is a parabola with its vertex at the origin. Here, x squared appears and y appears, but x and y do not appear together at the same time. Therefore, this is not a parabola with its vertex at the origin. It's not that, because it doesn't have all the elements that I just saw there. Let's see. I'm out of Cartel plus Z, so let me erase here. So, this one isn't it? It says, ellipse with center outside the origin. That's not it either. This one isn't the answer either. We know it's not an ellipse, for the simple reason that in ellipses we have x squared and we also have y squared. So, it's not an ellipse now. Ellipse with center at the origin? Well, no, because it's not an ellipse, since in ellipses you have x squared and y squared. Now, for the parabola with the vertex outside the origin, that's right. Yes, it is, because one of the two equations would look like this. And, sorry, y minus k squared equals 4p times x minus h. If we expand this, ay squared will appear. Now if we expand this, it also appears. And, right, and here, if we expand what's on this side, x will appear. So, as you can see, and well, obviously there will also be terms that have neither x nor. And let's see. I'm going to expand it quickly, because I don't want you to think that I didn't want to explain it to you. Look, let's expand this. So, what would I have left? I squared minus twice the product of the first and the second, that is, minus 2ky, and plus the square of the second, that is, plus k, squared, is equal to 4px, so 4px, and then 4p times minus h, so that would be minus 4ph. Now, I want you to notice that here we have something with y squared. Let me change the color again, y squared, which is over here. We have something that has y, here is something that has y, and we have something that has x. We have something that has x. This is a constant. And this is also a constant, right? And over here, we have a constant as well. So, as you can see, if we're dealing with a parabola with its vertex outside the origin, then what do you need to remember here? Simply, well, just remember the equations. So you do need to remember the equations of the line in its standard and general form, and of the circle in its standard and general form, and also with the center at the origin, and not at the origin. You should remember, well, something very similar. Also for the parabola, with its vertex at the origin and with its vertex not at the origin, you should also remember for the ellipse and also for the hyperbola. Okay, in each case, use the center or vertex based on whether it's at the origin or not. That's what you need to remember, right? That's why I was telling you. It's absolutely necessary that if you find the analytic geometry part complicated, then go to my channel. Really. Go, look for the playlists and start watching all the videos. Because if you don't, it's going to be very difficult for you to pass the exam. Well, that's all for today. Thank you. I hope the video was helpful and, above all, that you liked it. If you did, please, I'm going to ask you to subscribe to the channel. And also, since you're still here, I'm going to ask you to recommend the channel to someone else. Think about who might find it useful. See you next time. Take care and behave yourselves. Bye-bye.